LICO's ChromaTOF Sync 2D offers advanced data processing options for Pegasus BT datasets. The software simplifies non-targeted characterization and comparisons by combining information for multiple GC-GC samples with full peak finding and deconvolution. Here we're highlighting an application project that used ChromaTOF Sync to explore food spoilage. We analyzed a pureed tomato sample when it was fresh and then every day as it changed over the course of a week. All of the time points were analyzed in triplicate by GC-GC with the Pegasus BTX. Here are representative chromatograms for each of these samples. Our primary analysis goal was to see how the chemical profile changed over this process. ChromaTOF Sync streamlines this task by processing all of the samples together and compiling analyte information into a single combined peak table. Here we can see some of the options for reviewing the data and the processing results. The table across the bottom shows the peak find results and information about the analytes, including name, similarity score, retention index, and other identification metrics. The deconvoluted spectral information and the library match are here in the top corner. The peak areas for all 21 samples are tabulated in the columns at the back of the table. These can be displayed with the values or as a heat map, which is one of the ways to visualize the peak intensity trends across the dataset. The trends can also be seen in the bar chart here at the top. This section also displays the chromatographic information. The linear traces can be overlaid or shown side by side, and the contour plots can be displayed from the last tab or in the pop-out window that opens from this icon. All of these options make it easier to review the analyte details and trends across the set of samples. For example, here we see hexanal. From the bar chart and the heat map, we can see that it was present in the fresh samples and that it decreased rapidly after the first day. There are a lot of interesting trends in this data, and we can see some representative examples here in this subset of the peak table. Some of the analytes that decreased are at the top of the table, and the bottom section shows some of the analytes that increased. There are a variety of time trends and patterns here, and we can see these in the heat map and by clicking on specific analytes in the table. Some started to increase right away, while others increased later in the process. Some increased steadily, while others were more abrupt, and some stayed at a consistent higher level, while others started to decrease. We can continue to look at individual analytes and their patterns from this table. We can also perform additional comparisons with this compiled data, like principal component analysis. Here in the scores plot, we see some of the overall trends between the samples and which are more similar to each other. The fresh samples are separated more on PC1 from the later time points. This suggests that they are more chemically distinct and that many changes likely occurred early in this process on that first day. We also see that the other samples move along PC1 in time order, with the samples collected after 1, 2, and 3 days grouping independently, and then the last 3 days all clustering together. This suggests time trends and that the samples started to have more chemical similarities to each other at the later stages of the process. ChromaTOF Sync compiled information about the entire sample set so that we could perform this type of non-targeted data review to better understand this process and these changes. Getting to this combined feature table is straightforward with a familiar data processing method. We start by creating a new alignment method in the ChromaTOF Sync software. We specify the alignment type and then select the samples to process from our ChromaTOF database. Then we set the data processing parameters like peak width, signal to noise, and expected retention shift. The library search parameters and retention index landmarks can also be entered before clicking Begin to start the data processing. After processing, the software takes us directly to the results where we can review individual analytes, perform additional analyses like PCA, and start to understand the similarities, differences, and trends in our dataset. In this example, we explored the chemical changes related to food spoilage, but this tool can help with exploring the chemical changes related to other process types, or it can facilitate the non-targeted characterization of many types of samples and applications for a variety of goals.